Now let's do the marking for 45-degree angle probe. We have the 45-degree angle probe. This is 45, frequency of 2 megahertz. Now half skip distance, let's mark for 45. It's 9.5 from the center of the well. It's 9.5. And just mark it this way. Let me erase the oil, clean it. Erase the lines previously what we have done. So it's quite simple. Just use this one, put it here. From the center of the well, I'm just marking. Same way here. And here as well. Mostly for a thin plate, you don't use 45, but we can test it. Then full skip distance is something like double of that. The double will be 19. So let me mark 19 as well. This is just for my reference. Let me just draw a complete line. So I got half skip and full skip. Now let's start the machine. Pressing the button. Now I'll straight away connect this probe. It's very easy to connect. Now just see what values you're getting. Just put the P delay values to 0. So everything is 0. I can see something over here. Let me just reset it first. What I've done is calibration trigonometry. Let me just switch this off. Okay, this looks nice. So the range what we have calculated is 39. We got the answer for range as 39. So I think we can go for 40 as a range. But before doing that, we want to calibrate the equipment. For calibration, we are using V2 block, the smaller one. And you have an index point, just put some oil on the index point, just put it over here. You can actually find the peak. Let me just increase the range. Yes, you can see. Gain value is too high. Okay, that's good. Now I'm just trying to find the peak value. So this is the peak, and the value should read as 25, but it's showing 35. So I'll be using this P delay probe, increasing the value of P delay to make it 25. So somewhere here I'm getting the maximum. So it reads 25. That's good for me. Now if I see carefully here, the index point is somewhere. If I match the index point, it's around, the peak is coming around something like 11.5. So I will note it down. The index point is 11.5 millimeter. Now our probe is calibrated. We are ready to go. But first, let's set the range to 39, or let's make it 40. So why we are keeping the range to 40? Because I want to see first leg and second leg and a little bit of beyond that. I don't want more area to be seen. So it's very simple. Just put oil, and you just start from this point. You can see why we don't use a small angle probe. It's a very good example, because maximum I can go is, you can see the start point is, I can go to fill with half skip distance. I cannot go beyond that full skip distance. This is the line for full skip distance, and I cannot reach beyond it. That's the reason why we don't select small angles for thin plates. You can see I hardly get any signal because I cannot cross it. You can see some signal over here. Yes, this is some defect which is appearing in third leg position. Here you got some defect as well. The center of the well. Yeah, here you got some defect. Here you got a pretty good defect. So I can take the reading of the defect. Reading we got as SA, sound path is 36.03. And based on this one, we have to do some calculation. And at what point do I caught this defect is just measure this thickness, this length. It's coming around 61. So if I take this point as reference as 0, it's coming around 61. So distance from the side of the plate is 61. Note it down, and you can actually see this defect is starting somewhere at this point, and if I just move it, it's a little bit long defect. So you can actually measure the length of this one starting from here till here. So this is the starting point of the defect. You have to measure both of it. The starting point is 59. The defect start at 59 distance and it ends around here. It ends somewhere here, and this distance is 73, I think 73. So this defect length, the flaw length is 59 to 73 millimeter. Same way you can just check throughout. We just got one defect. We'll do the calculation to calculate what is the flaw length and so on. But there is one more thing. You have to calculate the distance of the center from here. From the center of the point, what is this distance? The y distance you have to measure. The y distance is coming as 30. Center of the well is 30 centimeter, 30 millimeter. Now based on this one, how did I calculate? I'm just calculating from the index point to the center line. That's coming as 30. This is how you do it. Now we're changing the probe. Now if I change the probe, everything will change. I have to again calibrate it. Now I just want to show you something. Some more feature of this machine is you have a function called trigonometry function. So I can use this function so that it gives me the direct value of the defect depth. I don't need to do the calculation. So we can just see if I make it. First you have to set the angle. So what angle you're using? Same angle, like you're using 45, so set it to 45. Then set the thickness 9.6. Then set the color to some range. Now you can see some purple color over here, then blue, then purple. So you are seeing something like 3 legs. It's able to calculate the 3 legs by different colors. So you can see if I'm seeing defect in this range, that means this is the third leg. This is the first, second, and third. And then you have the last part. So you're getting a defect in second leg. You see a blue color peak over here. So this way I can easily know which leg I'm getting the defect. Second leg, now I got a defect in third leg. If I bring it closer, this is the same thing getting in second leg. And also it has some more features. So you actually have to set the values of discrete quantities. We have to set it. Now you can see I've set it to depth. So he'll give me the depth value of the defect. I just need to bring the probe. So I got some defect over here. So he's directly giving me the depth value at which value you're having the defect. I'm having this defect at a depth of 6.75 because already I have set the values, so it will straight away give me those values. Now if I want to see other things, like I want to see what is the projected distance from this index point till where is the defect. So if I set it, we can see it's showing 26.25. At 26.25 distance from the center point, I'm having this kind of defect. So I can just set it to 26. This is 26. So exactly at this point, I'm having a defect. So I'm getting somewhere very close to the well, and maybe this is a lack of fusion. So we are getting at the boundary of the well and the base metal. So this is one way of doing it without doing any calculation. So let's start using the other probe.